Dear students, greetings from Dr. K. Sindalmuran, Associate Professor and Head Department of Information Technology, Kagatya Institute of Technology and Science, Warangal. In this video lecture, we are going to discuss about insertion sort. In previous video lecture, we have discussed about bubble sort and selection sort. What are the time complexity of the bubble sort and selection sort? So now we are going to discuss about insertion sort. These three sorting techniques also we can call like in-place comparison sorting algorithm, because it is compared with the place and we are swapping the values as per requirements. Then finally the array will be sorted. So based on this technique, we can say these are the algorithms are considered as the in-place comparison algorithm. This is week 11, lecture 3, classroom discussion topic 33, insertion sort. So before starting our class, we must be discuss about lecture outcome. After completion of this lecture, students will be able to develop a C program. To develop insertion sort program to sort the given n elements. If any elements we will give, that should be sorted using insertion sort program. So we are going to discuss about concept of the insertion sort and how to implement the insertion sort, and concept through dance video. Those things we will discuss in this video lecture. What is insertion sort? Insertion sort means, so we know that we are playing the cards. If we have 12 or 13 cards in our hand, we will check the first card we will take, we will compare with the remaining values. When we are checking that where it is exactly placed, okay, it is lesser or greater, we will check. If it is lesser, it will go for left side, it is greater, it will go for right side. Like that, we can insert. So if we have the playing cards in our hand, you just imagine it. We'll take the first card and check it is the smallest value or not. So whatever it may be, you will take the second value, will compare with the first value. It is lesser or greater, we will change it. So third card we will check. In case we will check with the left side, it is lesser than first card, greater than second card. If it is there, it will go for first place, or otherwise it is greater than first card and lesser than second card, means it will go to in between the first and second card. Like that, we can insert that. So when we are thinking this concept, we have to see the implementation, then easily we can understand that. Okay. So if the selected unsorted card is greater than the first card, it will be placed at the right side. Otherwise, it will be placed at the left side. So similarly, we can do all the operation till the entire array elements will be sorted. Okay. So like when we are doing this operation, we have to compare with all the elements. So each element we will take and it will compare with the previous elements. So it may be average case and worst case may be order of n square. The best case is order of n. So if already it's a sorted, means we can do that. But compared with quick sort, heap sort, merge sort, so the insertion sort have the less efficient because it will, the performance is order of n square. Okay, so simple steps to how to achieve the insertion sort we will discuss now. First, we will take, if the element is the first element, assume that it is already sorted. So return 1. Pick the next element. So we will take the next element and store it separately in a key. So now compare with the key with all the elements in the sorted array. Okay, so left side it is sorted array, right side it is not sorted. Like that, we will take and we will compare and insert on perfect place. So finally, we have to insert the value at a given position. So then repeat until the entire array will be sorted. So see, so example, this is the unsorted array. We'll take the initial arrays. So first we have to take 12 is sorted. You assume that you will take the second value. You will compare with 12 and 31. So it is greater than 12. So no need to swap anything. It is already in the ascending order. So no issue. 12 is sorted in the sorted subarray. So now again 31 and 25 will check. Okay, when we will take the 31, 25. So when we are comparing it, 31 is greater than 25. So then we have to 31 is not correct in the position. So what we will do? Now swap 31 into 25. Along with swapping, insertion sort will also check it with all the elements in the sorted array. So once we are shifting to 25 into 31, it will compare with the 12 also. So 12 is lesser value, so no problem. Then 25 will be placed in the second location. Okay, so 35 is placed in the second location. After that, again third value will compare with the fourth value. Now 8 is there. We will take 8 in comparison with 31. So again swapping is required. We have to swap it. So after swapping, again it will compare with the sorted array. 8 with the 25. So again it is lesser. It will swap. Then again it will compare with the previous value 12. So again it is lesser. Then 8 will be shifted to first place. So these are the steps we are using for that. So finally 8, 12, 25 will be sorted. The remaining 3 elements are there. So 31 again compared with next element 32. There is no swapping is required because already it is greater. So no issue, it is already in sorted order. So again 32 and 17 compared with this 17. While we are comparing with 32 and 17, so it is greater value, again it will swapping. So after swapping 17 with 31, it will comparison will be there. Again swapping is required. 17 will comes to previous position, 31 will goes to next position. Then 17 will 25 will be compared here. So this comparison will be again swapping is required, it will be swapped. So after swapping here, it will compare with previous values. These are the sorted values. So the 17 is placed in the particular position. After that, the entire array is sorted. So this is the method of insertion sort working procedure. Okay. So the best case of complexity is already the elements are sorted. No need to swap anything means it is order of n. One time we are comparing all the elements. So that is order of n elements. So average case and worst case, again we have to compare with the previous elements. So in case the elements are jumbled order and it is not properly ascending or not properly descending. So any order it is not there means it will take order of n square. So that means suppose we have to sort array elements in ascending order, but its elements are in descending order. So what happened? Worst case. So even in the reverse order means again we have to change it into the ascending order. It will take order of n square. So now we'll see the program. First, what we have to do, we have to do the insertion sort procedure. Only function we have to see here. The function to sort an array when the insertion sort is happening. We will take that value, I value first it will take, and we will take this value. Initially temporary, this temp value we can store that a of I. So initial value a of 1 it will take. So a of 0 is already assigned. So that is initially it is stored in the first location. You will just take that a of 0 is the sorted way. So then a of I will take that value will be assigned to jump. Then j value is I minus 1. So after taking the I minus 1, what happened? J value is I minus 1 means 1 minus 1 0. So j is 0 or greater than that, and temp value is less than or a of j. Then we have to do the swapping. Okay. So if the swapping will be happen, then it will go for j minus 1. So after this while loop, this condition is failed, then only it will come out, then temp value assigned to a of j plus 1. So after sorting that, we can print this using this for loop. So how we can call the function using that size array, we can declare size of the array, we can send as n value. Before sorting array, we can call the print array a comma n. Insert function we will call with the array and the number of elements or size of the array. And after sorting, we have to call again print array. So this is the sample examples we are given for insertion sort. So I hope there is no doubt for insertion sort. If you have doubt, once again we will go back and watch the video once again. Okay, so now we are discussed about implementation concepts and basic things about the insertion sort, as well as we are discussed about time complexity of insertion sort. Okay. So now this is the reflections part 1. The array elements are jumbled order, that is not properly ascending and not properly descending. So what is the time complexity? So already we are discussing the time complexity 3 methods. So now I will give 10 seconds time. You just answer it. If your answer is correct, no problem. You can proceed further. Otherwise, we will go back and watch the video once again. Then proceed further. Okay. So it will take 10 seconds time. Okay. So this is the answer. If you have written the correct answer, this is average case. Okay, it is not properly descending, it is not properly ascending, then it is considered as the average case. When average case means n value will compare with n other values. That's why n square is the time complexity. So we are discussed about insertion sort, what is insertion sort, how it is working, like playing cards, how we are moving the cards that we are discussed. After that, each array we are taken some examples, how we are comparing and insert the elements in the proper location that we are discussed. Finally, we are discussed with the program. Okay, so now we can try to take the n values and sort it using insertion sort technique and find the time complexity also. So I hope you are enjoyed this video. To end of this video, we can revisit the lecture outcome. Having completed this discussion on insertion sort, now students should be able to develop a C program to sort n elements using insertion sort. So dear students, if you have any further doubt, you can visit the textbook which is authored by Rima Taraja. So further doubt will come to class for classroom discussion. Thank you very much for listening this video lecture. Thank you all.